Okay, great to meet all of you. Great to be up here in Davis. I'm now a professor at UC Santa Barbara. My primary appointment is in the Department of Political Science, though I'm also affiliated with environmental studies, with the Bren School, and direct something called the 2035 Initiative that I'll mention in a few moments. I've taken a fairly meandering place to end up in political science as the sort of my intellectual home. So I'm Canadian. I grew up on the east coast of Canada, on the Bay of Fundy, which is a lovely part of the world. If anyone hasn't been there, has sort of the highest tides in the world, as a function of the horseshoe shape of the bay is like very well calibrated with lunar cycles. So you get up to 6 or 8 meters of tidal change. So the little village, I grew up in a small fishing village, and sort of the fishing boats at low tide are sort of on the mud flats, and then they go all the way up to the top of the pier twice a day. So I grew up in a really lovely place. I think it oriented myself towards caring about environmental issues. I basically did a botany degree as my undergraduate degree. Was actually deeply fascinated by lichen biology, and I think I almost went into I enjoyed school, I enjoyed research. I almost went into the sciences, and I probably would have done some soil carbon management work, thinking about how climate change was shaping mycorrhizal networks, and I can kind of imagine that alternative history where I'm sort of in a lab using tweezers to sort of measure the amount of sort of mushrooms in the soil. And then I didn't. I also did a sort of a major in international relations and botany as my undergrad at the University of Toronto. And I think I just felt more uncertain and less, I knew less and felt like we knew less about some of the social sides of these environmental issues that I cared about. And so I sort of went in the other direction. So I did my PhD. After a bunch of stops along the way, I eventually did my PhD at Yale in the School of Forestry, but working with a political scientist, doing a lot of my sort of disciplinary work in the political science department, and then using some of the methods and the lenses that political science offers to think about climate change. And sort of my dissertations really focus on trying to understand differences between countries and the timing and the content of different climate policies. Did a lot of work on Australia, Norway, here in the United States, and ended up at Santa Barbara for a couple of reasons. But one is just as many of you know, there's sort of an incredibly rich and deep community of environmental scholars on campus. It's a legacy in some ways of the massive oil spill that happened in the channel near Santa Barbara in '69, caused the university to have one of the first environmental studies departments, but then also, there's been sort of systematic network effects where more and more departments and more parts of campus realize that it's strategic to specialize in environmentally oriented scholarship, because then they can attract top scholars. And so we now probably have the largest, well, I think we definitely have the largest cluster of political scientists studying environment, probably anywhere in the world. And that's complemented by just a really rich community of other folks. So that's led us to start something recently called the 2035 Initiative, which I'm the director of now. And it's essentially like a think and do tank at the university, really focused on sort of applied policy roadmaps towards energy system decarbonization, both here in the United States and around the world over the next decade. And it's a fun group because it brings together people with sort of really deep substantive expertise in climate policy, energy policy, including folks in the social sciences who are deep within the weeds of lobbying for how the IRS should interpret IRA tax credit codes, but brings all of those folks into partnership with engineers, energy modelers, and helps us really think about how the social sciences should be collecting data to better inform California-wide transmission models, or really thinking about what knowledge needs to sort of be in place from a social science perspective that can then help support all sorts of energy system planning and energy system policy making. So, I've always had my feet in some ways on both sides of this topic, but I've moved more towards the social science side, and now I'm kind of moving into a place where I'm really trying to think about how social science methods, political science methods, can more deeply inform some of the more engineering and energy system problems that I jointly care about. So I'm going to kind of offer like a buffet style presentation today, and partly just because I think there are really rich ways in which, say, a political scientist like myself, or people who focus on public opinion scholarship, can actually be informing energy policy making. And it felt to me like it might be fun to sort of do a walk around some of those methods, some of those ways, hopefully to give everyone maybe some inspiration or ideas on how to connect social science work into, all of the really important stuff that you all are studying here. I really welcome questions, interruptions, so please stop me, ask questions, tell me these results don't make sense, you name it. Okay, and so let's sort of do a survey of different natural problems, systems in the state. And in doing so, I just want to showcase like a whole bunch of different ways in which social science has something to offer to some of these debates that is often missing, right? Because if we think about it, we think about energy policy, we think about climate policy. There's actually a really high degree, for instance, of spatial resolution that now exists in how we think about the economic impacts of different or of climate change or climate policy. We obviously have like incredibly detailed models of sort of climatic conditions. We have really great models, increasingly down to the substation level of the energy grid in the state. There are all of these parts or features of the world that we have developed really sophisticated, spatially resolved understandings of, or at least models of, and yet there's to some degree, well, there's a national pole, or we have this impressionistic sense of, is there political will to do X? And what I want to offer is that there are really interesting ways to go deeper and think much more spatially about people, and to do so in a way that can actually integrate into all sorts of more engineering, energy systems, or even science-based models. Okay, so I'll start by using the example of wildfires in California to talk about some of the ways in which we can use sort of election data to think a little bit about how people are oriented towards energy policies. Talk a little bit about, and I'll use the example of solar rooftops to think a little bit more about other types of political databases and what they can tell us about renewable energy uptake. And then I want to move into thinking about some of the different ways in which we can sample and collect our own data on public preferences, public opinion, but in a way that like intersects much more cleanly and usefully with other sorts of energy and energy system models that folks might be doing. Okay, so obviously we've all suffered from the accelerating number of wildfires in the state, and I think that there has sometimes been a wishful thinking that as sort of the impacts of climate change materialize, that's going to somehow transform the politics of climate change. It's going to transform the politics of energy, so that people will connect their direct experiences, and that will translate into willingness to pay for both important and ambitious adaptation policy as well as mitigation policy. And California is actually an interesting place that we can think about this precisely because it's one of the states, obviously, in the country that has a large number of ballot initiatives, including ballot initiatives that have, engaged a variety of clean energy and clean energy transition policies. And so we might ask ourselves, like, are these direct impacts, are experiencing some of these climate impacts actually shaping people's interest in, supporting energy policy itself or clean energy policy itself, right? So here's a study in which, we're mapping sort of the spatial extent of wildfires across the state, including matching those wildfires down to like a very granular electoral precinct level, and then, assessing the degree to which immediate exposure to some type of wildfire event in between sort of an election cycle over a 2-year period, is that shaping people's willingness to vote for what are in effect like costly energy policies, right? Because, it's one thing to say that one supports an energy policy on a survey, but are you willing at the ballot box to vote yes on a ballot initiative that would in fact, at least theoretically impose costs on yourself in exchange for energy or climate policy benefits? Oh, wrong way. And so here we find that there is an effect, though it's very spatially resolved, right? So, we find a 5 to 6 percentage point increase in voting for costly energy policies if you've been exposed in the last year and a half to a wildfire, but by around 15 kilometers away from sort of the boundaries of that wildfire, that effect is decaying, right? So we have this real sense of the degree to which some of these political effects may be really spatially resolved. I have a colleague at Santa Barbara who's done similar work looking at the spatial decay of voting against an incumbent government who has supported like wind turbines and sort of big renewable energy development. And again, we find this spatial effect, but one that sort of decays fairly quickly, and then in some ways it becomes a matter of assessing how expansive are these experiences in order to think about whether they're impacting elections. Go ahead.
Small question
Sure.
about the wildfire,
Yeah.
not about the results.
Okay.
Did you measure distance from the fire, also how it affected? We here in Davis were always more than 15 kilometers or 20,
Yeah.
but deep in the smoke pool of,
Yeah.
of the fire.
In this case, we don't. I have since sort of begun collecting some of the sort of smoke exposure data, which you could do. But yes, so if anything, you might imagine it to be a somewhat conservative estimate. But on the other hand, I mean, it's a bit complicated, right? Because the smoke is obviously not radiating equally in all directions, and so I think it confounds the results in complicated ways. And so no, this is just direct exposure to acres burned, like the perimeter of the burn. Yeah. We can divide. Oh, go ahead.
Is the percentage of people willing to vote for a environmental measure proportional to the size of the nearby fire?
You have a stronger effect with slightly larger fires, but no, it's more just about how close their house was to the perimeter, right? So it seems to be an effect of their experience. Okay. Yeah. We can divide sort of all of the electoral precincts in the state into terciles, just based on historical Democratic or Republican vote share. And what we see is that this effect is largely being driven by sort of the tercile of electoral precincts in the state that are most Democratic, right? And so what this is saying in some ways is that to the degree that direct experience is shaping people's attitudes towards energy policies, they need to be connecting their experience with, in this case, like climate change, right? So if you're not understanding your experience as linked to a policy problem, then you're not going to be responding to that in the way that energy or climate policy advocates might hope. And so it points to the importance of thinking even at the local narratives that exist about how people are relating to their experiences, because that's going to mediate the impact those experiences might have on willingness to engage in different energy policy behaviors. Go ahead.
Do you think that this effect could also have been caused just by the partisan divide between urban and rural spaces? Because, like, for example, if you live in a more urban area or suburban space, then a wildfire might feel more unexpected and impactful,
Yep.
and you're more likely to maybe vote Democratic if you live in a more urban or suburban space rather than in a rural
Yep.
place.
Well, I'll say two things. One, I'll show you, like, not going to sort of present everything, but we do a bunch of sort of robustness and sensitivity analyses to think about exactly this. So one's just showing that, like, if you take non-environment and energy related ballot initiatives, you sort of get null results, which is like a sort of helpful placebo effect. And so to the degree that you think some of those confounders are also correlated with other measures of ideological preference, we see no effect. The other thing that we do, because this is a panel study, so we can do a bunch of simulations on what level of omitted variable bias might need to exist to undermine our willingness to interpret the results as causal. And so, you know, what we can show is the strongest predictors that we can think of, like historical wildfire propensity, the partisanship, right? So these like political and environmental predictors, you would need like an emitted variable that's like 5 to 6 times more important than partisanship in explaining both treatment and the outcome variable in order to sort of have enough of an effect to confound in that way. So, you know, there very well may be some moderation of the effect by unobserved confounders that we can't control for, but we have a really hard time finding or even conceiving of confounders that, you know, are in this like 5 to 10 times more important than like the things that theoretically we think are the most important. So yeah. I'm fairly confident in it. I'm happy to share more of that with you, but
no, I was just
yeah.
really curious about that. Thank you.
Yeah. Okay. So this is one way of, you know, building spatially resolved political data into our work. Let's sort of think about another way in which we can exploit sort of observational political data sets to make sense of the energy transition. So, you know, some of you have probably sort of seen Google Sunroof. It's a great resource. We became really curious to try and understand, like, whether people were moving towards adopting solar PV as a function of, you know, their ideological commitments or simply as a result of the financial incentives, either through solar leasing or through, you know, net energy, you know, NEM policies or whatever it is in the state or place. And so what we did is we sort of decided that we would take a representative sample of households with solar PV across the entire country, right? So we did this by in a stratify sampling census tracts across the entire country based on sort of the ranges of households with solar PV that Project Sunroof sort of provides, and then for each of those census tracts, developing a way of like random walking around those census tracts to choose a representative number of houses with the solar panels, and then getting those addresses, right? And then sort of going into the voter file and collecting all of the objective data that we could find about people's partisanship, political participation, propensity to vote in elections associated with that sort of stratified random sample, essentially a stratified representative sample of solar households. Right, and so what we find, we sort of find two facts. So one is there is a, just so you know, like there's different, obviously different states collect different information about people's partisan attachment, right? Some states actually collect party registration, so you know if they're registered as Democrats, Republicans, Independents. Some states don't collect that as part of their voter file, and so you have to rely on essentially a modeled partisan score that, you know, estimates a probability of being a Republican or Democrat for every individual in the voter file. You know, so we see here that yes, it is the case that across the country there are more Democrats than there are Republicans who have solar PVs on their house. But this is actually a function of the types of places where there is solar, rather than some within community or even within state sorting into adopting solar or not, right? So what we've also done here is for every solar household, every address for which we've sort of identified that address via sort of the Google Sunroof as having a solar panel, we've also collected a random, within I think 50-meter spatial buffer, a random sample of neighboring houses, right? And so we can look at, for instance, the partisanship, voting propensity of the solar houses versus the neighboring houses, right? And so what we're finding here is that, in fact, even though it turns out that there may be more Democratic than Republican houses with solar, but an individual is just as likely to be a Democrat or Republican within their community. I mean, another way, let me put it a bit like this instead. Sort of no matter what spatial resolution you look at, the distribution of people's partisanship is proportional, among solar households, is proportional to the distribution of partisanship more broadly in that community, right? So if I dropped you in front of a house anywhere in Davis that had a solar PV, the likelihood of that house being a registered Democrat would be exactly the likelihood of being a registered Democrat in Davis, and so on and so forth, every other part of the country, right? And so this is actually fairly powerful evidence that there's more of a material set of incentives that are driving this. We also tried to sample we stratified sampled, and so that means that we could look at what about if you're like the first house in your census tract to have a solar PV, right? So versus in a census tract where there's like enormous numbers of solar PV. And that the same pattern is holding, right? So it's not even the case that if you're an early adopter, that there appears to be like some sort of ideological signal. Again, like that proportionality that we're finding overall is sort of holding in that circumstance.
Is that sort of bipartisan push to the sides due to like wealthier households that can afford solar? Are those households more likely to be strongly partisan?
Yeah, so what it is also the case in the paper that we find, for instance, that obviously wealthier households are more likely to have solar. People who have solar are more likely to be high propensity voters, right? They're more likely to be politically active, and so that actually suggests that they may be more easy to mobilize within the political system to, say, push back against retrenchment efforts. Yeah, somewhat older, more likely to have a home, be homeowners, all of the things you'd expect. But again, even conditioning on those, right, like conditioning on those wealth, it's not that like wealthy Democrats are more likely to have solar than wealthy Republicans, right? It's actually the wealth that's driving things. And so it does suggest as well that there is a constituency within both parties that might be mobilized in the event of sort of serious retrenchment efforts. And we've seen that. If we look at Nevada, if we look at Colorado, we look at Arizona, and sort of, for instance, efforts to repeal, household-level solar PV policy. Some have been successful, some have been less successful. Thinking about efforts to essentially impose grid charges via varying means on households to, pay their fair share of grid services as they're, exiting the grid by producing their own electricity. There has been mobilization, and it has not always had a very partisan flavor, right? There's been people involved in opposing, for instance, like Arizona ballot initiatives that have been deeply sort of involved in Republican politics there. Yeah.
How do you get partisanship data for households?
Oh, well, the voter file, right? So like, there are probably 7 or 8 different companies. So almost all states make voter file data public, right? So take the state of Michigan, where I've done some work. Michigan releases a voter file that gives everyone's name, address, and their voting history, right? And that's true of most states. The only thing that, not who they voted for, but like whether they're a registered Democrat or Republican, have they voted in this primary, have they voted in this election, and they update that like every day during election season, right? Now, some states don't have party affiliation in their registration database. So instead, you just know sort of their name, address, and whether they voted or not. Now, there's a number of sort of companies that essentially I've sometimes used directly that data. For instance, I'm doing a bunch of work around some of the electrification ballot initiatives that are happening in Washington State. So I just asked the Secretary of State to give me their voter file, and they sent me their voter file because it's publicly available. But there are also companies that are continuously like accessing that and collecting it and sort of turning it into sort of essentially a cleaned up database of every voter in the country. And those companies often are also appending other forms of public data that about each individual, right? Including like what they know about their gender, their income, their race, and et cetera, and all of that. Did they vote in the Republican or Democratic primary if there's an open affiliation? So that is then allows them to create this imputed partisan, like a probability of partisanship score for those states that don't sort of release the actual partisan score. But yes, like you could purchase your own voting history from one of these companies or just ask for it from the government.
What sort of work are you doing in Washington? Are you doing work with CETA?
So I've given some advice to some of the NGOs on sort of how to frame opposition to these ballot initiatives. In this case, we're going to do we are particularly interested in understanding undervoters. So who are the voters who are going to vote against these energy and climate ballot initiatives? Well, the two of them, but I'm actually more interested in the effort to sort of roll back sort of household electrification rather than the carbon price one. But you have all these people who will vote like for the Democratic ticket and will vote against, vote to essentially repeal these energy and environment-related ballot initiatives. And so we're really interested in understanding like what explains that deviation from sort of the straight partisan voting on it. Are these people who sort of have more dependence on sort of fossil fuels in their community for economic, and since we have a sense of like which precincts those undervotes were in 2016, when sort of the previous in 2018, we'll sort of sample places that undervoted in both elections, in one election, in neither election, and to try and like get a richer sense of who and why, who these people are that are sort of moving away from sort of energy and climate policy commitments at the ballot box, sort of despite the signals they're getting from the political messengers they trust, as a way of understanding more like where the tensions are going to exist in the transition. So yeah. Okay. So those are some examples of the type of work our lab is doing, bridging some important technology or policy energy variables with election results or voter files. We're also doing a lot of work generating samples on our own, a lot of the work that I'm doing involves thinking really carefully about which types of people would be most informative in structuring policy guidance or in thinking about some sort of energy problem, and then doing the legwork to actually collect data on those individuals, right? And so I just want to offer a couple of examples of ways in which the scope of what you can collect, may be broader than you think if you just sort of imagine buying a national sort of poll for like a couple dollars a person. So first, let's talk about power outages. This is actually work, a couple of the papers that I'll present in the next few slides are projects that have also involved Mark Lebel, I'm sure, who many of you know, who's been a close collaborator on several of these efforts. So we were really, obviously, I was very interested in trying to understand not just people's experiences with wildfires in the state, but also thinking really carefully about how people are adapting to the the inconveniences of public safety power shutoffs, and how these very dramatic disruptions in sort of service delivery might be shaping people's energy policy preferences, their attitudes towards the utility like PG&E, and their willingness or interest in taking a variety of different mitigation or adaptation behaviors, right? Because we need to recognize that the impacts of climate change aren't just going to be experienced through like a wildfire or a hurricane. There's actually all sorts of systems in our world that will begin to break down or shape or change in how we're relating to them. And so, obviously there were just a staggering number of power safety shutoffs in sort of November 2019. Sure, many of you remember this really well. So we, in real time, were collecting all of essentially the shape files released by PG&E across these successive outages, and essentially using that. And so I'll just say, all of this analysis excludes Sonoma. That was sort of where a lot of the wildfires were happening at the time, and so you would have a lot of compound and complicated sort of experiences in Sonoma County. But outside of Sonoma, we were collecting essentially the full de-electrification shape files in real time. And then we use that to do sort of a really high resolution spatial sample of people across the area. So, we have sort of the substations in the areas that had their power shut off, and then we're sort of going to do a representative sample of all of those areas with an oversample of a 1 kilometer buffer inside the shutoff areas and then 1 kilometer outside the shutoff area, so that we can try and look at people at the shutoff boundary as sort of a geographic discontinuity to see how that might be shaping people's sort of attitudes. And then also sort of a broader 20 kilometer buffer outside of the shutoff area. So here's sort of the overall map. And here's sort of a bit of a grid inset. This is just sort of each of the points here is sort of a single address that we sort of invited via a mailer to participate in this study. Okay, so there's a couple of things that this allows us to do. One is it allows us to collect really interesting representative data on people's experiences, right? So here is just sort of representative data from a representative sample of outage impacted respondents, right? So this is sort of a representative sample of everyone sort of inside the outage zone, right? And we can assess the type of concerns they had, what were some of the issues that were animating them, how long did they lose power, what type of costs or sort of adaptation behaviors that they need to do within sort of this outage period. So go ahead.
Just a clarifying question. I see you have 352 respondents. That's huge for a survey. How many people total did you survey?
Well, so this is just people inside the outage.
Yeah.
So surveys like this, the response rate, I'd have to look, was somewhere between 4 and 5%.
Okay.
Which is actually like fairly good for sort of mail-to-web surveys of this sort. And but yeah, so we generally, for California mail-to-web work that we do, it depends on sort of the timing and the nature of it, but around like a 4 or 5% response rate is reasonable, is sort of reasonable estimate of what we can do.
Mail-to-web?
Oh yeah, sorry. So in this case, we're sending people mail-based invitations, right? Those mail-based invitations will have, for instance, both a survey link that's custom to the individual, but also a QR code that you can scan on your phone. They're going to take that survey on the internet, right? On sort of like a web-based platform that we've developed. And so we will call that mail-to-web in the sense that we're able to precisely control who's entering the survey. Every individual has their own unique QR code so that we know exactly who has entered the survey. We can customize some of the information they receive based on
You know their address because you sent to them.
exactly. And I'll show you an example of how we exploit that in a moment. But then it's collected on the web, and then their compensation is through a digital gift card that they get sort of upon completion of the web survey.
Does this survey include both planned and unplanned outages?
The sampling frame, so if we did this within a couple weeks of the PSPS events. The sampling frame is based on planned outages, because we're sort of sampling based on who PG&E said they de-energized. We ask questions about people's actual experiences, right, that lets us, accommodate or conduct the analysis in a way that's responsive to people who we thought, based on PG&E data, didn't get de-energized, but report they did, and vice versa, right? So the sampling is done based on, the sampling is done based on what PG&E reported to have done. And the shapefiles were the reported de-energized areas. It is not impossible that they were the planned de-energized areas, rather than, I don't have an insight into sort of how accurate the PG&E reporting was. My sense is it was pretty accurate, and that we find pretty good congruence between what people report to have experienced and what we anticipated. But the sampling is done based on PG&E reports on what they did. And it was done immediately after the planned outages. And so, this is unlikely to be picking up, unplanned over the course of the year outages that are unrelated to the power safety shutoff events. Okay. And so what we do is we essentially are using this geographic continuity to restrict our sample in a way that allows us to try and match and control for all sorts of other confounders that might exist. And so we can look a little bit at how experiencing the outage is shaping people's adaptation and purchasing intentions, right? So people are certainly going to buy a lot more diesel backup generators. Kind of ironic. I mean, not a perfectly reasonable individual level response. But collectively counterproductive, right? To all commit to burning more fossil fuels as a result of a fossil fuel consequent activity, and a little bit on home batteries, a little bit on wildfire robust landscaping, but notably a reduction here in intention to purchase an electric vehicle. And so I think that this is an interesting approach to thinking about the interaction of experience and energy policy, because it sort of points to some of the tensions that might exist in sort of adaptation and mitigation policy planning. I'll also just say that this was not a great event for PG&E. So very significant increases. It says completely distressed the utility, but you should interpret that as, outage exposed residents much more significantly completely distress their utility, and also believe the utility is completely responsible for those outages. Though interestingly enough, didn't really change liability attitudes, and given all the conversations at the time about restructuring or even state takeover of PG&E, sort of there were lighter, suggestive but non-significant increase in some of those attitudes. Okay. So that's one way that we could use this quote-unquote mail to web approach. Let me offer you another one that's more climate adaptation and less energy specific, but kind of thinks a little bit about how we can really tailor in a precise way the questions we're asking to the sampling method we're using. So obviously, these sort of bathymetric sea level rise maps have become a really standard tool in communicating the risks of climate change. And this is from Climate Central. NOAA has one. There's sort of been a collective sort of assumption that this is a great way to sort of make salient and concrete future sea level rise risks and then induce people to take adaptation behaviors. Now, along with Mark LaBelle, we actually did a study of the Bay Area about almost 7 or 8 years ago now, using a commercial sample. We essentially hired a company to give us people who had Bay Area zip codes. And when we showed them examples of these maps, well, first of all, we found that people felt that other people in the Bay Area in the U.S., in the future were going to be more exposed to sea level rise than they themselves. And even when we tried to sort of show them some of these top-down maps, it actually seemed to have a backlash effect. It made people less concerned about sea level rise. And we published this, and we sort of felt very confused and unsatisfied about what was happening. Was it the case that we were getting people who were living in the Oakland Hills and then saw these maps and decided that they were safe, even though their water treatment facility was right on the bay. So I went back into the field and did a much larger study using this type of high spatial resolution sampling effort. Again, in the Bay Area, also in some select communities on the East Coast, essentially where we modeled what a sea level rise, like a bathymetric sea level rise scenario looked like by 2100, working with FEMA to choose places that had particularly surprising, quote unquote, flooding perspectives. Maybe the barrier island actually has a bit more topography, but then because of inland rivers or inland marshes, you'd have some, inland flooding that people might not be imagining in a 2100 scenario. And then again, sampling people within a kilometer on either side of that projected 2100 sea level boundary. Right? So we were going to sample residents based on their address living within a kilometer of projected sea level rise exposure boundaries by 2100 to more deeply think about how these risk-exposed populations are engaging with this information. Okay, and just to show you some descriptives here, right? So we're getting pretty good continuous response rates, within each 100-meter increment away from sort of these projected boundaries. And to be clear, most people wouldn't know what those boundaries are. So this survey and our experiment that I'm going to show you is exposing them to this information in a sort of specific way. Okay. So what does this look like? Well, here's two examples from the paper. Because we know everyone's address, right, we can actually randomize whether people receive one of these top-down sea level rise maps. We know their address, so we can actually present them with a flood map for their specific neighborhood in which their houses are going to be marked with a red star, right? So we can give people as customized as possible a version of this information. So here's two people, one person who's sort of flooded and one person who's sort of just on the edge of being flooded, to give you a sense of who these households are that are being sampled and what they're receiving from us as researchers in this experiment to test their adaptation preferences.
You said this sort of backlash effect. I feel if I don't know, just from my perspective, if I got a thing in the mail that showed my address and it also had a map of sea level rise and then asked me a survey about how I feel about sea level rise, I would feel there's an agenda there, which it's y'all are a university. But if I just got that in the mail, I don't know who this is. Is this an agenda? You know what I mean? Is that a concern?
So you might imagine that some people will have emotional reactions to the act of taking a survey. I mean, there's things that we do to try and mitigate that, right? So the invitation letter itself is not going to mention the topic of the survey. It's going to explain there are policy issues facing your neighborhood. We'll often ask a variety of different policy questions so that it's not all just climate and energy. And we'll also structure the sequence of questions so that if there's a more important question like this, it will come earlier so that it's going to, in social science terms, it's not going to be primed or as conditioned by what people think, right? And so there's all sorts of structural things that go into good survey design to mitigate that. And then you look for subgroup effects, right? So is it the case that people report more conservative ideologies, or say people you might expect to have a higher affective backlash? Is the effect concentrated amongst them, or in fact, is the effect concentrated amongst everyone? we find systematically that this backlash is actually concentrated amongst people who already believe climate change is happening and accept climate science.
Do you guys ever survey or are allowed to work with like insurance companies? Because I know like proximity of like a place here to like a flood area definitely changes your insurance, right?
Yeah.
So,
Well, we asked people about their insurance. We asked people if they knew their FEMA flood zone. I think it would be really interesting to work with insurance companies on a project like this.
probably aren't open, right?
Yeah. I mean, I would love that. So first of all, a few descriptives, and then I'll give and I'll probably just say one or two more things after the study, and want to create enough space for questions. So first of all, we find the same pattern, right? So, these are the people who will be flooded, right? Who are personally going to be impacted. They themselves, whether they're inside or outside the actual zone of being flooded, are not actually perceiving themselves as the most sort of vulnerable people in, they think their community is going to be a little more vulnerable in the United States, even more vulnerable, despite the fact that these are literally the people in the United States who are at the front lines of this issue.
You said personally, but what year is that?
So I'm just going to say that this is all in reference to 2100, and so that is a really. But I'm going to show you something else that is going to mitigate that particular concern, because we anticipated that is yes.
Not going to be
Yes.
flooded by 21.
Yeah, so I agree that. What I would say, though, right, is that even if you ignore the personally, right, the fact that people sort of think the United States generally is going to be more impacted by 2100 than their community would be something that even you would, that's not a gradient that even you, if you didn't think you were around in 2100, would be feeling, right? Yeah.
Do you have an idea if this is a representation of what people actually think or what they want to believe? I mean, those two are probably fairly inseparable, but
Yeah.
you mentioned something about clever survey design.
Yeah,
Does that
so-
help you separate those ideas?
So a couple of things, and let's see if you feel somewhat more resolved on that. So the first thing to say is that if you do an experiment where you show people these maps, right, the maps are reducing people's concern about sea level rise, both for people living chest inside and chest outside the sea level rise zone, okay? And in fact, this is a bit complicated, but this is just showing that you're seeing significant effects, and there's not really a clear difference sort of at that sea level rise boundary. It's also the case that it has the expected effect on wanting government support for coastal adaptation. So people do not want to see any rezoning, so any type of individually costly policy has no effect on. But even as they're less concerned about sea level rise, they're actually quite a bit more supportive of having the government subsidize sort of coastal insurance. But it's also the question about is this something about people finding, oh, in 100 years I'm just going to barely be inside the flood boundary, so I shouldn't care so much about it. So in the Bay Area, we simultaneously sort of did another experiment on the same sample, where we were offering people information about commute time increases in 2100, right? So this is sort of, you've probably seen this, the folks at Berkeley who sort of have a pretty good commute network model for the Bay Area, essentially derived from tracking cell phone data. And what you can essentially do is you can flood the roadways, sever different road connections, and then simulate people traveling from the same places to the same endpoints under this sort of reshaped road network to generate a neighborhood level estimate of commute time increases, right? So this means that so then when we tell people, well, actually, you will have a commute time that is 10 minutes longer in 2100, or people in your neighborhood will have a commute time that is 21 minutes longer as a result of sea level rise, right? We see sort of massive increases in concern across sort of all of these dimensions, right, including personal, right? So, even to the degree you're right, which I think there's real. I mean, so why we chose 2100 because this is what people, for external validity concerns, this is what people are actually saying and doing out there. But we, even sort of anchoring on that 2100, there's something about this particular top-down approach that's actually generating backlash. And there's some psychological theories that explain why this is the case, right? So people process risk very differently in the abstract versus in a more concrete way. And so there's probably what's happening here is a lot of people who accept climate science have a very generic abstract fear of sea level rise. And then when they get specific information, it changes that abstract fear into a more specific fear, and then they rank it differently on a survey. And so, the finding here is just when we think about risk communication results, we need to be really, really thoughtful about how to empirically test them and what their results are going to be on the ground in the communities that we're trying to target. And this is where this type of high resolution work can be helpful. Okay. Oh, this is the wrong, sorry, this shouldn't say climatic change, ignore that. This is under review right now. I'll just say that another thing that we do, so I do a lot of work with digital advertising sampling. So for instance, using Facebook advertisements in very structured spatial ways to recruit hard to reach people into surveys. So this is actually from we've done a large survey of all the small island states and territories all around the world, and generating representative samples of climate adaptation, sea level rise, energy policy preferences within these communities. Here's the South Pacific folks. We've also done this in the Indian Ocean, in the Caribbean. And essentially using Facebook as a way to recruit people into representative surveys that otherwise sort of would be inaccessible to climate policy planners. I have a whole sort of branch of work that does really fine-grained sort of spatial modeling of climate concern around the world, essentially using a really big Bayesian model that is sort of, you feed into it all the cross-national climate opinion data, millions and millions of respondents that's been ever collected, that it spits out sort of the latent variable of climate concern in national and subnational levels. Many of these small island states have never been surveyed, even ones that have a lot of significance in the popular imagination, right? The Maldives, Fiji, never been included in any survey that thinks about sea level rise, right? So this Facebook advertisement approach is another way that as social science researchers we can access hard to reach populations. And all to say, so I'm just showing this because it's actually kind of interesting. So each of these gray two-letter labels is a ISO 30166 sort of code for a small island state or territory. But what I think is interesting is this is kind of the inverted version of that risk perception graph I showed you for the folks in the Bay Area. And so what's interesting is that these very climate vulnerable coastal residents in the global south, yes, they understand that they're vulnerable, much more so than people in the Bay Area, but they also have a more flat relative perception of vulnerability than folks in the global north, right? So they are actually finding rich countries to be similarly vulnerable to climate change or sea level rise as they are, right? There's much less of a gradient here than we see here, right, in sort of the Bay Area sample. And so I think it's not that, so we actually sort of see a flattening of relative risk perceptions in some of these coastal vulnerable regions in the global south. So just an interesting addendum on this topic. Okay, so I have lots and lots of other projects we could talk about, and I just want to maybe tell you about a few of them in the very broad strokes to give you a sense of the work that we're doing at the 2035 initiative and sort of in my lab. So right now we're doing a really big survey of California households, partnership with folks at San Diego and Berkeley and some energy modelers at Santa Barbara. And basically the objective is to think about demands on the state grid that are going to result from electrification trajectories, particularly thinking about electrification in disadvantaged census tracts in the state, and thinking about how that's going to intersect with the need for investments in various transmission or grid capacity. And what we're doing here, though, right, is, and this is unusual for social science, but I think speaks to where these different ideas intersect. So we're actually like sampling based on the geography of feeder substations, right? So we are, in this case, like dividing by climate zone and census tract, but also looking at, for instance, feeder lines that are estimated not to have available capacity, and then specifically looking at like what are the preferences and propensities and attitudes of houses on those feeders to see whether, are they similar or different than, say, state averages? What does that mean for, how we should sort of allocate various investments? And we're collecting a large enough sample here that we can also downscale or essentially use a bunch of social science methods to estimate the specific propensities for adoption, at the census tract / feeder substation level. And that sort of provides a more granular indicator of human behavior that you can then input into some of these larger grid models and sort of run them forward under different scenarios. Lots of other stuff that sort of has that flavor, right? So we're working with a lot of solar developers to sort of collect panel data of people living near planned and prospective large-scale solar sites, understand how different interventions might be shaping sort of community attitudes towards those developments. Similar work looking at offshore wind, where we can sort of evaluate people's willingness to accept offshore wind based on, for instance, where they live and what the sight lines might be as a result of sort of their location of residence. And similar work on fossil fuel phase out in an equity perspective. So in the US, looking at sort of abandoned oil and gas wells, both in California and also in Appalachia, and then sampling people living within a certain distance from those uncapped wells, or sampling people within a certain distance of various fossil fuel facilities to better understand sort of what type of stranded skills or perceptions of compensation or attitudes towards the clean energy transition might exist in each of those contexts. Okay, so let me leave it there. But to take a step back and just summarize, what I hope this kind of smorgasbord of different research projects has offered is sort of a flavor for all the different ways in which, the human factor, the sort of public, sort of political systems, can be measured and studied at a much more high-resolution spatial scale, and one that, and I think this maybe wasn't as easy to do 20 years ago because of a lot of reasons. Mail to web was more expensive, but there's a real significant amount of advances that have happened, I think, in sort of social science capacity to collect structured high-resolution spatial data. And I think it's providing an opportunity to build that data into energy policy planning and also energy policy research in a way that grounds and makes precise, political and social factors. And I think that's to the benefit of our understanding of energy systems, because we know that technology and economics are not enough to sort of support an energy transition. There's also the political dimension of the energy transition, and I think that there are more and more opportunities to build that into the models and decisions we make. Okay, let me leave it there. So thanks so much.
Can you talk more about your ongoing work with the panel data of households and the prospective solar facilities?
Yeah, so this is work that is getting started right now. It's funded by the Department of Energy as part of the Solar Energy Technology Office sort of has a large grant-making program to sort of support community acceptance of LSS sites. So this project is working with a couple of different partners, but so there's something called the Uncommon Dialogue at you know about the Uncommon? Oh, you are? Okay, great. Yeah. So this is in partnership with those folks, and so maybe you SI2.
Oh, SI2. Okay.
Yeah.
I'm on the agrivoltaics one.
Okay, cool. So I think that the agrivoltaics, I think that probably your working group will be engaged as well, but But fundamentally, what will happen is the Uncommon Dialogue siting group in particular is being tasked with generating ideas for a number of different interventions to support community acceptance. More on the LSS side, less on the agrivoltaic side. And there's a team of developers who are part of the Uncommon Dialogue who have committed to implementing some of these innovations in a series of different communities across the country in the next couple years. Our job sort of as the social science team at the 2035 initiative is we are essentially putting in place panel infrastructure to be able to test the causal impact of those innovations. And so that's both, a large part of that is putting in place monitoring in these communities in advance of those innovations so that we can then sort of track differential trends in community attitudes through time. It also takes advantage. I have a close colleague at Santa Barbara, Grace Wu. Yeah, you know Grace, right? Okay, so Grace has a great model, right, of the, on the agrivoltaics, but she also has a pretty good model of LSS, like for large parcels of land in the U.S.
Large-scale solar?
Yeah, like what is the likelihood or capability of that large parcel of land to have large-scale solar, right? And so we sort of have an estimate of the suitability of large-scale parcels of land for LSS siting. So that can give us sort of like a baseline sort of set of sites across the US. We can look at interconnection queue data to kind of get a sense not of prospective but planned. And then we know these developer sites and sort of alternative. And all of this essentially lets us create a panel not just of the specific places where these innovations will happen, but comparable places where it's not happening. And it's sort of a 3.5-year project then to sort of measure and track the attitudes and sort of community receptiveness of these developer actions. Yeah, cool.
I feel like I know the answer to this, but I just wanted to make sure. When you say households, you mean like just homeowners and not renters?
Either.
Okay.
I mean, a household is going to be an address. Now, usually, usually when we do this, right? So, if we're doing some sort of sampling frame development, right, and we'll have, like, let's go back to sort of this power outage map, right? So, what do we actually do here, right? So we have these spatial polygons that give us the spatial extent of an outage. To generate a representative sample from that, we will sort of like overlay that with a raster file of population density, right? And essentially do a weighted random sample of geographic points within those polygons to whatever sample size we want. And then there's a variety of ways we can do this, but we'll reverse geocode those points to the nearest residential address, right? You can do that either through sort of a Google API, or often Microsoft has a building footprint for a variety of parts of the world, so you can actually overlay the building footprint. So the point is we're doing like a weighted random sample of lat longs, and then using a variety of processes to reverse geocode those to the nearest residential address, which is then like the address that we send the mailer to. That address could be a rented address or a homeowner address. We say household in the sense that we're only sending one invitation to each address, and then we're collecting data on who within that household is like the one who's answering the survey. But there might be multiple people living at that home, and we're not sort of sending multiple invites based on that. Okay. So that's household then is sort of an indicator for like the unit of sampling is the household, and then we have to do some modeling of within household variability. But the invites are going to the household level, not the building level or the individual level.
So for an apartment, it'd be like a particular unit. Well, that's really reassuring. I feel like as a renter, I'm often left out of anyone's considerations in terms of energy.
Yeah, I mean,
I don't have much control or freedom in terms of energy efficiency or what kind of energy or basically anything to do with any of that. So it's nice to know that at least somebody's asking.
Yeah, I mean, I want to be careful. Like, it depends on the survey, right? Like, sometimes we will choose not to sample residential dwellings that are more than a certain number of units, right? So it depends on what the object of analysis is, but there's no reason why it can't be either or depending on the need. Yeah.
Okay. Did you also look into difference, for example, for like the sea level rise thing? How it differs between like people who rent a house or like own a house? Because I would imagine that someone who owns a house is more concerned about their house.
You would think so. They're surprising. We found a surprising absence of differences on. I mean, a little bit, but like my priors would be that there should have been a stronger difference. Yeah. But again, it was, and both renters and homeowners very, very interested in commute time. So.
I think it's kind of interesting. The people in the Bay Area don't really think that much about flooding. But do you think that could be because of the infrastructure? Because people in the underdeveloped communities think more about it, because if a flood happens, their homes would be like totally destroyed, and if something like that happened in the Bay Area, I don't know if they would lose everything like they would in an underdeveloped community.
Yeah, I think that's possible. It's interesting. Like the research that we have on this risk communication side of things, particularly in like the U.S., I think that there's probably too much emphasis on some of these bird's eye sea level rise maps and not enough on systemic infrastructure risks. So, one thing that I think would be really interesting, and we've been talking about, is for the Bay Area particularly, right, is that there's actually a lot of infrastructure systems, obviously, that people rely on that is far more vulnerable to even small amounts of sea level rise than people are perceiving. And as you guys also know, like the Bay is kind of like a ticking time bomb in terms of sea level rise, just because say you harden the Bay, it would just cause even more dramatic flooding, right, throughout the entire area. So one interesting thing, and we've been beginning to collect some data on wastewater treatment facilities, right, which in the Bay Area are almost all like essentially deeply vulnerable. They're all in low-lying areas, right, but they're providing drinking water or wastewater management way up into the hills, right, and so I think it would be very interesting to explore that. So when you discover that your drinking water is actually like right on the coast, even if you live like at a couple hundred feet elevation, does that type of message look more like the commute time message or more like the flood map message? And so got too excited. There wasn't much in it, so that's good. But my strong intuition is that a bigger focus on systemic issues is actually going to be quite a bit more helpful when it comes to communicating sea level rise. But honestly, I think that's true broadly on all sorts of different impact-related measures, right? So if we're thinking about energy policy planning, thinking about some of these more systemic risks and systemic disruptions can actually be driving people's attitudes and intentions more. And that's why we've been having this research stream on the public safety power shutoffs, because those type of disruptions themselves to infrastructural sort of stability, may be actually shaping people's sense of vulnerability.
Could you speak to some examples of policy impacts from some of these studies? Like, I understand how they could affect policy, but have they affected policy, or what kind of decisions have been made based on this data?
Well, the data that I've showed you today has been more on the retrospective analysis side of things. Obviously, like the sea level rise study is having an impact on how various agencies are like communicating sea level rise to their constituents, right? I think this data we're collecting right now is an example of like one of the more policy focused sort of studies that we have in the pipeline, right? Because we're collecting social science data that will be fed in the next couple months into a variety of different sort of scenarios, and that's going to sort of generate specific guidance to energy policy planners and the CEC and the Public Utility Commission about like where there is likely to be like more instability in the grid under these different electrification scenarios and where there'll be less, right? So there's I think a lot of value here in sort of converting attitudes and intentions into sort of a form that is more accessible and legible, right, to certain types of energy planners. I should say, like, the broader political science work we do is also sort of points to, me and many of my colleagues are very involved in sort of, pushing for different provisions in the IRA, for instance, that, we're responsive to, our political economy analysis of how to sort of grow power to more clean energy interest groups and reduce power of fossil fuel interest groups in the context of, the transition. So there's sort of like a high-level strategic type of impact, and then there's efforts to take social science data that kind of otherwise might sit in a that's really interesting, but how do I apply it, and convert it in a case like this into data that is directly legible within sort of existing sort of planning systems, right? Yeah.
I have a question about this one because I think I missed something.
Sure.
The research question here is their likelihood to electrify their households, and then just the sampling frame you're using the feeders.
So this project is really trying to think about equitable electrification policy in California. That's what it's sort of been funded to do. And so, but so there's a range of different teams working on it, right? And many of them have like pretty, so Duncan at Berkeley's involved, and Patty Hidalgo Gonzalez at UCSB, right? And so and then Ranjit Deshmukh at who's sort of a former student, or Dan Kamen, sort of professor at Santa Barbara, and so their bread and butter is always sort of scenario-based energy system planning, right? So like running the energy system forward and the grid forward under a variety of different constraints and different demand scenarios, and then assessing what type of vulnerability / investment needs would be required to sort of meet demand in those various ways. So the role that like the social science can play here is generating sort of substation level estimates for propensity under a variety of different scenarios, so that we're actually creating like a high resolution image of potential individual level behavior and intention to electrify that can integrate into sort of those models, right? So we'll know what is the willingness to pay among someone living in a climate zone and a disadvantaged census tract, and therefore like this feeder in this part of California. And then we could imagine that there's a policy response that reduces cost by 20%. That's going to sort of move the willingness to pay of these individuals. Another 10% of this feeder would actually then like be modeled as willing to pay and therefore willing to adopt these technologies in this period. And so it helps to sort of add more granular information about human intention and human perception and sort of attitudes into sort of the scenarios themselves.
Okay.
Yeah.
The feeder itself has no impact on this household decisions.
No. So that's right. But the
post process of what feeder they're on.
Yeah, but so people obviously have no idea what feeder they're on, right? But the point is that we want to understand the sort of forward-looking behavior of individuals, and so by sampling based on feeder, we're sort of sampling in a way that allows for aggregation of these propensities. We're collecting social science data in a way that I don't know that people have ever sampled on feeders before, but like if you want to integrate like fine-grained, high-resolution spatial understandings of propensities into a model like this, sampling on feeder and sort of collections of feeders is a great way to sort of collect the data with less sort of crosswalk measurement error, right? Yeah. So that's sort of the idea here, is that like we sample on feeders because it then structures the social science data in a way that docks and integrates into the end use model better. And the point is that like we have this system with mail to web and sort of we have like a system for somewhat actually quite cost effectively doing this to collect like a different type of data that's tailored to actually support like the end use outcome. That's the
That makes sense.
Just a follow-on question. In your communication of the survey and the recipient of the mailer, how much do you describe how they got selected? Like how much of that detail do you share?
Well, I mean, it is sort of like like even if you were selected because of a climate zone feeder combination, like you're still randomly selected amongst like tens of thousands of people who could have been the person, right? So we do not, we explain the overall purpose of the project. This will inform energy policy planning or whatnot. We also have like, work of this sort, for instance, we have a community advisory board made up of community, like a variety of different community stakeholders across the state, representing, a variety of different interests in a lot of the disadvantaged communities that are like the target of the grant. And so that community advisory board has been involved in sort of helping to construct the introductory language in advising on question wording and making sure that the type of questions are accessible, appropriate, and also like supporting like local needs and sort of local desires to understand different features of people's energy systems. And so then the way the survey is presented is also sort of being screened and supported by their sense of how this engagement should be undertaken. Yeah.
So I'm curious, when you guys are doing retrospective analyses to like disruptive events like the PSPS,
Yep.
or I don't know if you guys are doing something with the recent hurricanes, might be
Yeah.
interesting. Are you guys scrambling to get these out in a certain timely manner? I'm curious about the like risk perceptions and how they might change over time, like if you wait too long.
Yeah. Yeah. So like the PSPS, yes, it was a. I mean,
And also,
it was a like, oh wow, like we ought to study this, and then it was like a scramble to get something into the field and through human subjects review and funded in like 4 or 5 weeks. I think we got into the field in 6 weeks after the events, which for a research project was great.
yeah.
But yeah, no, there's a certain amount of having infrastructure and capacity to do the research in place, and then scrambling to take advantage or to leverage things that are happening. And because exactly right, if you wait a year, learning associated with that event sort of has decayed, and you need to have a certain amount of nimbleness.
Yeah, I can only imagine the logistics
Yeah.
associated with that.
Applying for funds will already kill it.
Yeah.
You need to have the money ready.
Well, I would just say, like, there are some, the PSPS, we had funds, like, obviously we all had funds that were responsive. But also, like, the Natural Hazard Center at the University of Colorado Boulder gave us a little bit of money for sort of but there are a couple of rapid response pools of money. But, we needed to be like path committed to do it whether or not we got that, and then it was great that it partially subsidized, right, what we're doing.
Have you studied much of the hydroelectric or nuclear responses?
No, though I haven't. I think there's a lot of interesting stuff to be done there, but no, we haven't personally. Yeah, go ahead.
Is there any interest or like movement towards doing similar work as the sea level rise in, say, the East Coast, especially Florida, for like hurricane damage, as like extreme weather events get even more extreme and common?
Yeah. Well, there's some interesting social science work on this. Often it has sort of a panel format where you're sort of longitudinally tracking individuals, and then you look at people who are exposed and you look at differential responses. So like econometrics, like what's called like a difference in difference framework. And there's a couple of, I think, pretty good papers that do that. It's a little harder to sort of generate non-confounded samples with hurricanes because they have such a broad spatial extent, and the power safety shutoff is like an interesting example of an intervention, like the very precise boundaries, right, and very arbitrary boundaries that you can then exploit to try and like think about the causal impact of that event on attitudes. You probably would need to, if you're trying to do a similar thing in a hurricane context, you'd have to look at like cones of uncertainty, like say 5 or 10 days out, and then think about sort of comparing people who got impacted by the hurricane versus people within some comparable cone of uncertainty bandwidth. So it's just a little trickier to do a rapid response analysis of a hurricane that has that causal flavor. Now, one thing I'm part of a group of folks, including at Stanford, that are setting up or working to set up and get funded what we're calling like a global climate adaptation observatory. But the idea here is to put in place monitoring infrastructure by impaneling people in longitudinal panels in a variety of climate vulnerable sites across the global south, like in coastal Bangladesh, or in a sort of city in Uganda that has like strong urban heat island risk. And we recruit those people based on their spatial location through Facebook advertisements, but then provide them like phone microcredit compensation, and then keep on sort of providing, based on text-based ongoing survey messages, sort of microcredit microcredit for their phone plan compensation. And if that network is sufficiently broad and well constructed, then you are able to look at how people are responding to a variety of these climate impacts over the course of a year or two, and have some of that pre-data along with the post-data to more reliably sort of think about the sort of causal impact and the policy needs with these larger scale sort of events. So that's kind of the approach that we're taking, but it's, you need to have slightly different approaches for each of these things, but there are, the message I want to put out there is there are really interesting ways to do this, and so if there's social science data that would be useful or helpful in the context of all of the various energy or policy planning work that you're doing, don't discount the possibility that there is a way to, flesh out the human factor in a more sophisticated way than you might think.
Yeah. It seems like it doesn't necessarily need to be in the immediate wake of a crisis, because with like the power shutoff, people, I guess the extent of harm caused by the power shutoff is not on the same magnitude as the extent of harm caused by a hurricane. Like,
yeah.
People might forget that their power and AC didn't work for a while in 3 or 4 months, but nobody's going to forget that a year ago I lost my home.
Right, but also the issue is that like many of those people who lost their homes will move away. And so like you actually lose the ability to even like, this is a big problem with a lot of impact surveys, and why you need to have this longitudinal approach, right? It's because if you're only measuring post hoc, it's really hard to understand like what the impact was. It's hard to identify impacted people, particularly in like more underserved or more disadvantaged communities. Like it's a total question mark. Whereas having a longitudinal monitoring infrastructure in place lets you understand like the scope of impact in a more sort of clear way. Yeah.
Thank you.
For the power outages study, did you consider that for example, PG&E might have sent out a notice saying like, hey, we're gonna take your power down at this time on this date, and recommend, for example, buying a small generator for your household if you really need it for the power for this period of time? Because the data showed that they wanted to do this, so I don't know if they were primed to do this by the generating company because there was a planned outage.
Possible. Right. I mean, like we're in this case like trying to identify the causal effect of the outage on intentions. You know, the mechanism through which that happens isn't something that we can parse in the study here, right? It could have happened through media exposure, PG&E communications, any of those things, right? So the mechanism is something that you'd have to more deeply like investigate. All we can sort of think about here is like the treatment effect, and then the mechanism would sort of be an object of proof. So it could be. I don't think that's not going to condition the effect. It's just the sort of speaks to our need to then like more deeply understand the mechanisms that would explain the effect.